All right, let's get right into it. Today, we're talking about a secret weapon that developers use to make their applications feel incredibly fast. It's a fundamental pattern called the cache aside strategy, and we're going to look at it using one of the most popular tools for the job, Redis.
You know the feeling, right? You're just staring at that little spinning circle, waiting and waiting for a page to load. It's so frustrating. But what is actually going on behind the scenes? Well, it turns out, more often than not, there's one single culprit causing the slowdown.
And there it is, the primary database. This is the official system of record, the main library where all the important data lives. And it's built to be super reliable and consistent, which is awesome. But that focus on safety often makes it the slowest part of the whole system. It just gets swamped with requests and is really hard to scale up.
So why are they so slow? Well, it's not just one thing. It's kind of like a triple whammy of performance hits that happens with pretty much every single request your app makes. So every time your app needs to fetch something, it has to pay these three tolls. First, there's just plain old network latency, the time it takes for a message to travel over the wires. Then, you've got the computational load. The database actually has to think. It's parsing your query, looking through indexes, doing work. But the real killer, the thing that slows everything down, is I/O latency. That's the physical act of reading data from a spinning disk, and that is just orders of magnitude slower than reading from memory.
Okay, so if the database is our slow, overworked librarian, how do we fix it? Simple. We give it a super fast assistant. And this is where our hero, caching, enters the story. It's a solution designed to take all that pressure off the main database.
At its heart, caching is a really simple idea. You're just storing copies of the stuff that people ask for all the time in a much faster place. Think about that librarian again. Instead of running to the back of the library for the same popular book over and over, she just keeps a few copies on a little shelf right by the front desk. That shelf? That's your cache. And when you use a tool like Redis, which keeps data in memory, you get some serious superpowers. First, latency basically disappears. We are talking sub-millisecond access times because you're reading from RAM, not a disk. Second, it just massively reduces the workload on your database since most requests never even get to it. And this also boosts your fault tolerance. If your main database has a hiccup or slows down, the app can keep on chugging, serving popular data right from the cache. Now, there are a few ways to set up a cache, but the most common, the most flexible one is called cache aside. And that word aside is the key. It means the cache sits off to the side. The database and the cache, they don't even know about each other. It's your application, sitting in the middle, that acts as the traffic cop, deciding where to get the data from.
Let's walk through what happens when someone requests some data. First, the app checks the cache. It asks Redis, hey, do you have this? Now, one of two things happens. Either it's a cache hit, meaning the data is there, or a cache miss, meaning it's not. If it's a miss, the app has to go on that longer journey to the main database. It grabs the data, but, and this is the crucial step, before it sends it back to the user, it saves a copy in Redis for the next person who asks. Then, finally, it sends the data back to the user.
And this is where you really see the difference. A cache hit is just this beautiful, clean, fast path. App to Redis to user. Boom, done, lightning fast. A cache miss is that whole longer journey we just talked about. The entire goal of this whole pattern is to get as many hits as you possibly can and avoid those misses. But there's a catch. This strategy has an Achilles heel. Our caching hero has one big weakness, and it's this. What happens when the original data changes? This right here is the central challenge of caching. What happens if a user updates their profile picture? That change gets saved to the main database, but the old picture is still sitting there in our super-fast Redis cache. That copy is now wrong. It's an outdated version of the truth. And this is what we call stale data. The cache is basically serving a ghost of information that's no longer real. And the scary part is, the application doesn't know. It sees a cache hit, and it just happily serves up that old, incorrect data to the next user, breaking the promise of data consistency. So how do we fight off these data ghosts? How do we keep our cache fresh and accurate? Well, luckily, there are two main strategies that engineers use to solve this exact problem. The first approach is passive, and it's called time to live, or TTL. And it's actually beautifully simple. When we save a piece of data to the cache, we just give it an expiration date. We tell Redis, hey, hold on to this for, say, 1 hour, and then just automatically delete it. It's a set it and forget it kind of deal.
But here's the thing about TTL.
It forces you to make a really important trade-off. If you set a very short TTL, like 10 seconds, your data is going to be super fresh, but you'll get a lot more cache misses, which means your database is still doing a lot of work. On the other hand, if you set a really long TTL, maybe 12 hours, your cache will be amazing at protecting your database, but you run a much higher risk of serving old, stale data. It's this constant balancing act.
For data that absolutely has to be up to date, we need a more active strategy. This is called cache invalidation. And here, instead of just waiting for data to expire, the application takes direct control and forcibly deletes the data from the cache the instant it changes in the database.
The process is pretty straightforward. So, your application updates a user's record in the database. If, and only if, that update is successful, the very next thing it does is send a delete command to Redis for that user's cache data. This guarantees that the next time someone asks for that data, it'll be a cache miss, forcing a trip to the database to get the fresh, updated version.
Okay, so we've got the passive, time-based approach with TTL and the active, direct deletion approach with invalidation. So which one should you use? Well, it turns out the best practice is not to choose. It's to use both.
And this is really the most robust, professional way to do it. You use active invalidation as your main strategy. When data changes, you zap it from the cache immediately. That gives you maximum freshness. But you also put a TTL on everything in the cache. Why? Think of it as a safety net. If, for some weird reason, that delete command fails, maybe there was a network blip, the TTL ensures that the stale data won't live in your cache forever. It'll get cleaned up eventually.
So, as we wrap up, it all comes down to this one fundamental question that you as a developer have to answer for every piece of data you cache. What's more important? Is it pure raw speed, or is it perfect up to the millisecond accuracy? The answer to that question is going to determine your entire caching strategy.